In section 2.3, we're asked to solve right triangles. And to solve a triangle just means that we're going to find the measure of all of the side lengths and all of the angles in the triangle. And so there's lots of different ways to approach this. Creating a table like you see on the right hand side here is a great way to organize all of your answers. So I'm going to start by just filling in the information that we're given in the question. So I'm given angle E. Angle E is my 90-degree angle. I'm given angle R, which is 51 degrees. And I'm given side length R, because that is the side across from angle R. And so there's lots of ways to start here. A nice easy place to start might be to solve for the missing angle. I know that all the angles in a right triangle add up to, or in any triangle for that matter, add up to 180 degrees. And so angle H, my missing angle, should be 180 degrees minus the other two angles. And so that should get me 39 degrees. Next, I've got all three angles in the triangle, and so I'm going to update my table here. I've got 39 degrees now for angle H. I've got all three angles in the triangle, so I have lots of different options to solve for side length H and side length E. I would recommend always using the values that are given to you in the question. And if you can avoid using a number that you maybe previously solved for, it just might be a little bit safer that way. Maybe if you made a mistake, you're not carrying that mistake through the entire question. So I'm going to try and use the 51-degree angle and the 2.5 millimeter side length in solving all these. So if I want to solve for side length E, then I need to be using the sine function, because I have the opposite side length and I want to know the length of the hypotenuse relative to my 51-degree reference angle. So I'm going to say that sine of 51 degrees is equal to the opposite side length, 2.5, divided by the length of the hypotenuse. And I'm going to rearrange this equation and solve for the length of the hypotenuse. And when I type that into my calculator, that should come out to about 3.2, and the units are going to be millimeters. Okay, I skipped a few steps there. If you are having trouble rearranging those, please refer to one of the earlier videos, or come see myself, or set up a meeting with myself, and we can review that together. And next I need to solve for side length H, which is the adjacent side length to the 51-degree angle. And I'm going to use the 2.5 millimeter side length, which is the opposite. So that means I need to be using the tan function. So tan of 51 degrees is the opposite side length divided by the adjacent side length. And so when I rearrange this, I end up getting 2.5 divided by tan 51 degrees, which turns out to be about 2.0 millimeters. Okay, and it's a good idea to look at our table here at the end and make sure this information makes sense. My largest angle should be across from my largest side, and so that's my right angle, 90 degrees, is across from my largest side length, which is the hypotenuse. Okay, my smallest angle then should be across from the smallest side, which it is. Okay, and I can see my angles are adding up to 180 degrees as well.